Hi guys, welcome back to the next part of what I should know for pre-calculus but may have forgotten. So today we're going to talk a little bit about functions and we'll review a little bit about functions. So before functions comes a relation. A relation is a set of ordered pairs. That can be a set of numbers such as ordered pairs that are numbers 1, 2, 2, 3, -5, 1. It can be a set of letters. It can be mixed. Okay, they can even be words. All right, it's just any set of ordered pairs. Now comes a function. A function is a relation, which means it's a set of ordered pairs, in which every domain element, x, is assigned one and only one range element, y. So what does that mean? That means that every x value only has one y value. In other words, the x values do not repeat. Graphically, we use the vertical line test. To determine if a relation is a function. Because remember, if you draw a vertical line, every x value on that vertical line is the same. So if a vertical line only hits the graph once, you have a function. If any vertical line can hit the graph more than once, you do not have a function. So let's look at a couple of examples. So here we have example 1. Okay, it's a nice set of ordered pairs. Is this a function? Well, what we do is we look at our x values. 1, 3, 7, 12. Did I repeat any values? No, I didn't. All my x values were used once. So yes, this is a function. Now in B, it is a set of ordered pairs, but we don't see the infinite number of ordered pairs. What we see is the graph. But if we look at this graph, anywhere we try to draw a vertical line, the vertical line can only cross the graph once. So yes, this one is also a function. However, if we look at C and we try to draw a vertical line, anywhere except x equals 15, that vertical line is going to hit the graph twice. So no, this is not a function, because in this particular case that I drew, when x is -10, y can either be 20 or -10. So that is not a function. Now we're going to break it down and we're going to look at domain and range. So the domain of a function is the set of all inputs. It's the independent values, okay? Usually the x values, but not always the x value. And the range is the set of all outputs. That's the dependent values. Okay, I should take this s off because I have the values there. Okay. So this is the set of all outputs, or the dependent values. Now, again, that's usually the y's, but not always the y's. Sometimes the function isn't defined in terms of x's and y's, all right? But it's what the dependent variable is, or whatever the outputs are. Now domain, let's go back to domain for a minute. So the domain, again, is the set of what's usually the x values, the independent variable. If there are no restrictions, then you can say, and this is the formal notation, the set of all x such that x is a member of the reals. The set of all x values such that x is a member of the set of real numbers. It won't let me write the S. There's supposed to be an S there. It won't let me write it. I can't figure out why. There it is. Okay, I had to write it a little lower. I don't know why it wouldn't let me write. All right, so the set of all, that's what the formal notation is. I'm okay if you just say X belongs to the reals and you can spell it out. Or if you write X belongs to R like this here, that's fine. A lot of times, and I do this out of habit because this is how my college professor did. And if you look in the textbooks, they always have, sometimes they write it this way with this double horizontal line on the R. That's a symbol for the real. Sometimes you'll see a fancy R in other textbooks. That just means the set of all reals. So when we're talking about X values, the X's are on that horizontal axis. They move from left to right. So it's really asking how far left does the graph go to how far right. So if you have left and right bounds, it's how far left, less than equal X, less than or equal to how far right. Now you may drop off that or equal to if there's an asymptote or an open circle, okay? You might not have a left bound, so you would just leave that part off, but those are the things that you look for. Now it's very similar with the range. The range is the possible Y values. And again, if there's no restrictions, you can say Y is a member of the reals, okay? Or just Y belongs to the real numbers. The Y values are on that vertical axis. They go up and down. It's how low to how high. So let's take a look at the same three examples we had before. So we're going to find the domain and range. Now, when I give you a finite set of points in this ordered pair, like in example A, you're going to give me a set of a finite number of numbers in there. Okay, you're going to give me this set, and you're going to tell me all the X values for the domain. My first X value is 1, my next X value is 3, my next one is 7, and my next one is 12. And you have your domain. Now the range, again, funky set brackets, not parentheses, not square brackets. This is a set. It's in the funky brackets. Guys, I know they're hard to write. If you just try that for now, I'll give it to you. Show that you're making the attempt. Trust me, I know. It took me a long time of practice in math to get to make these, okay? I will not criticize your drawing capabilities. Do the best you can. So now for the range, we're looking for the Y values. 2, then 4, then 5, and then it's 5, but I'm not going to write it again. Do not put the same number in more than once. That's our range. We're done. Let's look at example B. So now we have a graph. This graph has an infinite number of points on it because between any 2 points you look at on this graph, there's another point. And there's another point in between that, and another point in between those two. There's an infinite number of points. So you cannot write your domain in range like this. You are going to have to use inequalities or interval notation. Okay? So the domain, remember, is the set of all X values, how far left to how far right. Now if you notice, this graph, yes, it's going right, but it's also getting wider and it's going left forever. Same thing here with this parabola. As it's going up, it's also going to the right and it's going to keep going over. This graph is going to go forever left and forever right, which means that my domain is the set of all real numbers. Okay? Now the range, those are my Y values. How low does this graph go? Look at this. The lowest it goes is a height of 1, less than or equal to Y. The highest, now it keeps going forever, so technically I'm done. That's one way to write that answer. It's okay if you wrote it as Y greater than or equal to 1. I don't care which way you write it. If you use interval notation, it starts at an inclusive 1 and continues to infinity, but non-inclusive. So you have the square bracket on the left and the parentheses on the right. All right, let's look at example C. We have another parabola. This time it's a sideways opening parabola. It opens to the left. Our domain is our set of all X values. Now this graph is going forever to the left. Now notice this is not a function. We talked about that before. But the graph is going forever left. but it does stop going at the right. So I don't have a how far left, but I do have x is less than or equal to 15. That is my domain. Now my range, also, you could write that in the interval notation, non-inclusive negative infinity to an inclusive 15, whichever way you prefer. Now the range is our y values, how low. This parabola is going to keep going lower here, and it's going to keep getting higher here. So that means the range is the set of all real numbers, okay? Y belongs to the reals, the set of all real numbers. All right? Awesome. Now we haven't done it algebraically when I give you an equation yet. So there's a couple things to remember. First thing to remember is that there's two huge things to remember when you're finding domain algebraically. First thing is you cannot divide by 0, and you cannot take the square root of a negative. You can take the cubed root of a negative, but you cannot take the square root or the fourth root or the sixth root. So really, you cannot take an even root of a negative number, okay? If neither of those rules apply in the problem, then the domain is the set of all real numbers, okay? So if there's no fraction and there's no even root, no radical, then the domain is all the reals. Now let's look at that a little more carefully. Let's get into this a little more. If you have the fraction scenario and you have a numerator divided by a denominator, we know that you can't divide by 0. So that means that your denominator cannot equal to 0. So you take whatever your denominator is, set it not equal to 0, and solve for x. Now, if you have a radical, you take the radicand, which is whatever's under the radical, and you cannot take the square root of a negative. So if it's not negative, it could be positive or 0. Positive would be greater than 0, but it's also allowed to be equal to 0. So we take whatever's under the radical and set it greater than or equal to 0 and solve for x. And then, of course, we have where you have a numerator over a radical so that our denominator is the radical. Well, we know that this radicand can't be negative, but we also know that since it's in the denominator, it can't be 0. So it's not negative, it's not 0. The only thing left is positive. So we take whatever's under the radical and in that denominator, set it greater than 0, and solve for x. Okay, so let's try this. We're going to go through and we're going to find the domain and the range of each of these. Now, when we do these, I'm going to be totally honest with you here. We are going to find the domain algebraically, but we're going to find the range graphically. We're not ready to do the range algebraically. We'll get there, okay? That's something new that's coming later in the unit. We'll get there. Right now, we're reviewing what you're already supposed to know. So we're going to do the domain algebraically, and we'll look at the range graphically. So let's look at the first example. F of x is the square root of x plus 81. So the square root of x plus 81, we have a radical. We know that when we have this domain, we take whatever's under the radical and we set it greater than or equal to 0. Then we solve for x. So we subtract the 81 from both sides and we have x is greater than or equal to negative 81. We now have our domain. Let's do all the domains first since we're doing it all algebraically. Let's look at B and we'll do the domain. So the domain for f of x is x cubed over 5 plus x. All I care about is this denominator, 5 plus x. That denominator can't be 0, so we set that not equal to 0. And we solve for x. To do that, we subtract the 5, and we have x is not equal to negative 5, and we're done. okay? I don't need you to put this in the set of all x such that x belongs to the reals, but x not equal to -5. Now, you going to college, if you might do this in college, you might see x belongs to the set of all reals except for -5. That is another way that you might see it, okay? Really, for our purposes, I'm okay with that, okay? For our domain, x not equal to -5. I am okay with that, okay? And we have one more example here. F of x is 3 over the square root of x minus 1. So this time we take what's under the radical, which can't be negative, but because it's in the denominator, it also can't be 0, so it's only x greater than 0. And if I add the 1, I get x is greater than 1. That's my answer. Now, of course, you can write this the open interval from 1 to positive infinity. And if you like interval notation back on 8, that would have been the inclusive -81 to the non-inclusive infinity. Okay? Now, we're going to go to our calculator and we're going to find the range for each of these. Okay, so here we are on the calculator and we're going to go to menu. We're going to put in a graph page and we're going to type in our first function, which is the square root, to control x squared, x plus 81, and hit enter. I don't see it. Why don't I see it? Because notice we said our domain is x is greater than -81. Our graph isn't going down that low, so I'm going to zoom out. Oh, look at that. There, I'm seeing something. I'm still not seeing a... Oh, look at that. It's not a parabola. It's half a parabola. Okay, so do you see this half of a parabola? That's why the x's are only greater than -81. Now, what about the range? Okay, now I'm going to make this a little lower. Let's see. Let's make this -100. Tab around. Let's tab here. Let's make this 500. Okay, and it's happening very slowly, but this is half a parabola, so it's going to keep going up and up and up and up and up. So our y's are starting here at 0, and they're going up and up and up and up and up. So our range here is y's are greater than or equal to 0. All right, I'm going to add another page. Control Doc to add a page, and I'm going to add the graph. This time I'm going to put in my second function. I'm going to use my fraction template. I want you in the habit of using that. I cannot stress enough the importance of using that fraction template. Honestly, before the calculators came out with that, it was unreal. When the calculators first came out with this fraction template, I would say about 85% of my pre-calculus mistakes that I got from students disappeared because they were calculator mistakes with fractions and parentheses. Please use the fraction template this year. Okay, so in the top we have x raised to the third. Then we're going to come out of that exponent, go down to the bottom, and we have 5 plus x, and we hit enter. And there's our graph. Now, if we're looking for the range, how low, it's going forever low. How high, it's going forever high. So we have our range is the set of all reals. I'm going to add another page. And again, graphs. This time, we have a fraction. So there's my template. My numerator is 3. My denominator is the square root of x minus 1. Hit enter. Look at my graph. I'm just going to slide it a little bit so we have a better view. Now this time, it doesn't look, and I'm keep sliding here, it's getting closer to that y-axis, but it's not getting there. Okay, so it's going towards the x-axis, but it's not getting there. That x-axis is a horizontal asymptote. It's approaching it, but it's not quite touching it. And then it's increasing forever in this direction. So this time, our range is the set y's greater than 0. The graph never actually hits the x-axis, so y is actually never going to be 0. Okay, so we took the answers that we found on the calculator. I added them to my notes here. All right, guys, hope this helped. I'll see you in class. Have a good one.